Welcome back, dear viewers. In today's session, we are going to discuss about refraction by spherical lens. In the previous lecture, we were studying about the spherical lens, and we have studied that there are two types of spherical lens, convex lens and concave lens. So in this today's lecture, we will study about the refraction by spherical lenses. First, in a convex lens, a ray of light parallel to the principal axis after refraction passes through the focus on the other side of the lens. In a concave lens, it appears to diverge from the focus on the same side of the lens. कन्वेक्स लेंस में क्या होता है, जो रे ऑफ लाइट जो पैरेलल होती है प्रिंसिपल एक्सिस के आफ्टर रिफ्रैक्शन, जब ये इसको रिफ्रैक्शन होती है, बेंड होती है, तो इट पासेस थ्रू द फोकस, ये फोकस से पास होती है ऑन द अदर साइड ऑफ द लेंस. इसी तरह इन ए कनकेव लेंस इट अपीयर्स टू डाइवर्ज फ्रॉम द फोकस. इट अपीयर्स टू डाइवर्ज, कनकेव लेंस में ये डाइवर्ज होती है कहाँ से, फोकस से, ऑन द सेम साइड ऑफ द लेंस. You can see second one is, in a convex lens a ray of light passing through the focus after refraction goes parallel to the principal axis. In a concave lens a ray of light directed towards the focus after refraction goes parallel to the principal axis. First one is convex lens. In this case, a ray of light passing through the focus after reflection goes parallel to the principal axis. Let's see. It goes parallel to the principal axis. This is convex lens. Let's see. आप concave lens में देखेंगे. ठीक, ये भी parallel है principal focus में. Now we will discuss third case. In a convex lens and concave lens, a ray of light passing through the optical center goes without any deviation. दोनों convex और concave lens में जब आपकी लाइट, रे ऑफ लाइट पास हो जाएगी ऑप्टिकल सेंटर से, तो आपकी जो वहाँ पे आपको कोई डिविएशन नहीं मिलेगी. आप देख सकते हो इन स्लाइड्स में, no deviation at all. Okay, now we will discuss about images formed by convex lens. First case is when the object is at infinity, the image is formed at the focus f2. It is highly diminished, real and inverted. You can see in this slide, it is my object placed at the infinity and image will be formed at focus f2. Okay, all right. Second case, when the object is beyond twice f1, 2 times focus f1, the image is formed between f2 and 2 times f2. It is diminished, real and inverted. You can see my object is beyond 2 times f1. The image will be formed between f2 and 2f2. Obviously. All right. Third case, when the object is at 2 times f1, the image is formed at 2 times f2. It is the same size as the object, real and inverted. You can see in this slide. Fourth case, when the object is between 2 times f1 and f1, the image is formed beyond 2 times f2. It is enlarged, real and inverted. Let's see in this slide, dear viewers. Obviously image is formed beyond 2 times f2. Okay. Case number 5, when the object is at f1, the image is formed at infinity, it is highly enlarged, real and inverted. Let's see. Case number 6, when the object is between f1 and O optical center, the image is formed on the same side of the lens, it is enlarged, virtual and erect. Let's see. Okay. Now we will discuss about images formed by concave lens. First case is when the object is at infinity, the image is formed at the focus f1 on the same side of the lens. It is highly diminished, virtual and erect. Let's see in this slide. Okay, all right. Case number 2, when the object is between infinity and f1, the image is formed between f1 and O on the same side of the lens. It is diminished, virtual and erect. Let's see. Okay, now we will discuss about sign convention for spherical lenses. The sign convention for spherical lens is the same as in the spherical mirrors. जो साइन कन्वेंशन हमें spherical mirrors में आ गई थी, वही साइन कन्वेंशंस इस spherical lens में है, except सिवाय एक के that the distance are measured from the optical center. In case of spherical, dear students, in case of spherical mirrors, all the distance are measured from the pole, but in case of spherical lenses, the distance are measured from the optical center. So my dear students, it is a worthwhile point to remember. Second, the focal length of a convex lens is positive and the focal length of a concave lens is negative. You should also remember that जो focal length convex lens की होती है वो positive होती है और जो focal length concave lens की होती है वो negative होती है. You can see in this layout. Okay. Now we will discuss about lens formula for spherical lens. We have discussed mirror formula for spherical mirrors. That was nothing, 1 upon u plus 1 upon v is equal to 1 upon f. But here is a little bit difference. The lens formula for spherical lens is the relationship between the object distance, that is u, image distance v, and the focal length. The lens formula is expressed as 1 upon v minus 1 upon u is equal to 1 upon f. It's most important for examination point of view. Second is magnification produced by spherical lenses. Magnification for spherical lens is the ratio of the height of the image to the height of the object. Magnification is nothing, ये ratio होता है किस किस के बीच में, height of image to the height of object. The magnification is also related to the दूसरे, in other words we can say that it is the ratio between the object distance and image distance. इसको हम कैसे express करेंगे? It is expressed, it can be expressed as magnification small m से दिखाते हैं, इसको express करते हैं h superscript में, ऊपर लिखते हैं I means object distance और नीचे image distance, that is v upon u. In case of spherical mirror it was minus times. Alright, now power of lens, it also comes 2 marks question. The power of lens is the reciprocal of its focal length but in meters. So dear students, what is power of lens? Power of lens is 1 upon f, means reciprocal of focal length, but it should be in meters. Or we, from this very relation we can write F is equal to 1 upon P. The SI unit of power is diopter. It is denoted by capital D. 1 diopter is the power of lens whose focal length is 1 meter. तो 1 diopter लेंस का पावर होगा जब उसकी फोकल लेंथ 1 मीटर होगी. द पावर ऑफ ए convex lens is positive and the power of a concave lens is negative. This point you should have to remember. This completes your chapter. Before we will go away, you are requested, if you are new to our channel, don't forget like and comment our channel. Also subscribe our channel, press the bell icon so that you will never miss an update for incoming videos. In the next lecture, inshallah, we will be discussing about the questions of this very chapter. Thank you.